Hey guys, Mr. Lang here. I'm just going to take you through Learning Target 9 Intro. Sorry I can't be there tomorrow. I wish I could. I wish I could be in two places at once. I've just got a family illness we're dealing with, so sorry I won't be here tomorrow, but I thought I'd come in real quick on my own time. What we got, 9 p.m.-ish on Thursday night, and walk you through the tangent. We haven't really talked about tangent with unit circle. And it doesn't really fit on the unit circle, does it? Because, right, what we discovered earlier, of course, is that the cosine of the angle would equal the x value, and the sine of the angle would equal the y value. Well, where does tangent fit into this equation? Clearly, tangent is not the point itself, because that's already spoken for, x comma y, cosine comma sine, spoken for. Okay, so the old way, remember, some of you actually had these bad boys memorized for 2 learning targets ago. You memorized the sine of 30, cosine 30, 1/2 root 3 over 2. You memorized sine of 45, cosine 45. They're both root 2 over 2. You memorized the sine of 60, the cosine of 60, root 3 over 2, 1/2. And you're like, oh, they're the opposites of each other, because it's the same triangle, you're just looking at it from 2 different directions. Well, now we have this awesome thing called the unit circle, where it's a tool that gives us the answers to all of them, right? So we go, the cosine is the x values, so we got 30, 45, 60, right, cosine, 35, 45, 60, right? So this tool gives us the answers to each. It gives us the cosine is just the x values, and then the sine is just the y values. This is 60, 45, 30, so 30 1/2. We all know sine of 30 is 1/2. How many times has Mr. Lang said it? Like a million, okay? Well, actually, we have a couple more to bring into the equation for sine and cosine, right? So before, we didn't talk about the point 1 comma 0. So the cosine would be the x, the sine would be the y at 0 degrees, or 360 degrees. So the cosine of 0 degrees would equal 1, while the sine of 0 degrees would equal 0, okay? Or we didn't really talk about all the way up here at 90 degrees, right? All the way straight up, 90 degrees or pi over 2. So the cosine is 0 and the sine is 1. So those also flip-flop. So if we go sine of 90 degrees equals the y value, that one equals 1, where the cosine of 90, that one equals 0. So just like 0 and 90, the sine and cosine flip-flop, just like 30 and 60, right? Same values, they're just the same triangle, we're talking about the same piece. And of course, sine and cosine of 45 are the same because they're literally the opposite and the adjacent are the same. Now, what about tangent? Some of you may already know the answers. If you memorized old school, you know already, what is the tangent of 30? What is that? Do you remember? Do you ever memorize? What is the tangent of 45? Do you recall what it was? What is the tan of 60? Sneak it right in here. What's the tan of 60? We memorized that. And now we have something else to consider. What about with these 0 and 1 situations? What would the tan of 0 degrees be? What would the tan of 90 degrees be? Or any other point on the unit circle, what would be going on with tangent? Well, it's not like SOHCAHTOA doesn't exist anymore, right? So we've been living in this world, this beautiful world of every single time the hypotenuse being 1, the h being 1, so right here, this being 1, this being 1, oh, but tangent doesn't have hypotenuse. So we didn't really do anything with it. It doesn't really fit with the points, right? We talked about how sine then of the angle is the opposite over 1. Oh, because 1, oh. We don't even need it. It's just straight up, the sine is the opposite, right? The sine of 30 is 1/2. The sine of 45 is square root of 2 over 2. The sine of 60 is root 3 over 2, right? It's just these y values are the answer. And we talked about the cosine, right? The cosine is the of theta would be the adjacent over the hypotenuse, which is 1. Again, we don't even really need the hypotenuse because dividing by 1 isn't going to do anything. So the cosine is just the adjacent, so it ended up being this one next to these angles right here on the bottom. So cosine of 30, cosine of 45, cosine of 60. It's just the x numbers, right? The x values, okay? Now, so we didn't bother because we knew if x, right, and y, where does tangent fit in? So the easy way to think about our good old friend tangent is to actually just use the triangles and calculate them again to see if you recall what those values were from a couple months ago. So let's start with classic 30. So tan, it's still the same thing. Tan of 30 degrees would equal the opposite still over the adjacent. Ew. Maybe that's why we didn't talk about it. A fraction divided by a fraction with a radical on it. No, thank you. Let's just come up to tan of 45. So the tangent of 45 would be root 2 over 2, the opposite, divided by the adjacent. Oh. Those are the exact same. And of course, we all remember anything divided by itself equals 1. You remember now, you remember the tan of 45 is 1. This was kind of, that was kind of like our star one. That was the one that most of you got right on that Unit 4 test. So, oh, because it's the opposite over the adjacent, and the opposite and the adjacent, opposite, adjacent, they're the same. Anything divided by itself is 1. So we're going to come back to tan of 30. What about tan of 60 degrees? So the opposite over the adjacent. Root 3 over 2 divided by 1/2. Man, these fractions, they're kind of rough. I feel like dividing by a half isn't too bad. Well, in both of these cases, what have we done before? What's historically, what do you do in math classes? You actually don't divide by fractions. I believe in middle school they told you keep, change, flip. We of course say the proper is instead of dividing by 2 over 1, get rid of that, we multiply by the reciprocal. All right, so same thing here. Instead of dividing by root 3 over 2, no, let's not do that, no. We will multiply by the reciprocal. All right, so let's start with tan of 30. Ooh, good thing we were practicing our fractions. I got a 2 on top, a 2 on the bottom, boom, boom. I'm left with 1 over root 3. A root on the bottom again. Well, we know that you have to rationalize that, so we multiply it by itself to make it a regular 3. Ooh, that's good, regular 3. But then we also have to multiply the numerator, the top, by root 3. So the final answer is root 3 over 3. Okay, so we kind of, what we do here is a side note, we say the tan is root 3 over 3. It's not one of the points, it's not x, it's not y. It's just kind of bonus information there that the tan of 30 degrees is root 3 over 3. Did you remember? It's awesome if you did. If you remember that because you memorized them like legitimately, boom, you got it. It's root 3 over 3 for sure. Then over here at 60, instead of dividing by 1/2, we're multiplying by 2. Oh, this one's easier, thank goodness. So these 2's would cancel out with each other, and you're left with √3/1. Oh, that just straight up equals √3. Oh, that's great. So again, we kind of do it as a sidebar. That is the point. It's not changed, but also BTW, the tangent would be just straight up square root of 3, not even a fraction. And I forgot to write it, but at least we forget it here in green. The tangent of 45 literally equals 1/2. So those are our tangents, kind of our sidebars, our extra information, if you will. Do you think those answers would ever change if we went this way, or this way, or this way? Or if we went into the third quadrant where you would have a negative over a negative, but if you divided a negative by a negative, wouldn't it be a positive? Or also, what about these guys? Oh, we forgot to talk about tan of 0 and tan of 90. Well, before we mention that, did you notice something, right? It's the opposite over the adjacent. 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 Sine is the opposite in the unit circle. Cosine is just the adjacent because there's nothing on the bottom. Literally, sine is the opposite. Literally, cosine is the adjacent. And if tangent is the opposite over the adjacent, so it's the opposite divided by the adjacent. It's the sine divided by the cosine. Here's all you gotta do, my friends. Here's the big reveal. So tangent on the unit circle will be whatever the y is divided by whatever the x is, right? Because it's the opposite over the adjacent. Look at these. That is the y. Y, 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 y. It's just look at the point. If you do y divided by x, 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 y divided by x. It really simplifies it for you. So any tan you want to find, tan of 330, tan of 270, tan of whatever you want, all you do is just on your unit circle, find it, and do the y number divided by the x number. So to kind of finish it, what about some interesting ones here? It's the y over the x, it's the sine over the cosine values, the y over the x, the y over the x, the y over the x. Oh, well, we already have the answers here. What would the tangent of 0 degrees be? 0 degrees, 0, the y divided by the x, the y divided by the x. Well, what's nothing divided by something? Still nothing. Okay, that's fine. So the tangent of 0 is also 0, just like sine, not degrees, sorry. 0, the value is 0. Okay, so side note, the tan would also be 0 here. So that's just, again, keeping our sidebar, if you will. Ooh, what's the issue here? The sine over the cosine, the y over the x. What's 1 divided by 0? Okay, Google, what's 1 divided by 0?
The answer is undefined.
Yeah, you can't divide by 0. You know you can't do that. So, weird, you actually are not allowed to take the tan of 90. We do want you to know exactly what Google said. It is undefined. Okay, so like the sidebar here, that point is 0, 1, but the tan is undefined. So also down here at 270, that would also be undefined because that would be -1, 0. The y is, sorry, that would be 0, -1. The y is -1, the x is 0. -1 divided by 0 would be undefined. So these two spots at the very top and at the very bottom would be where your tangent is undefined. All right, so that's kind of a summary of everything. Let's move on over to the notes packet. So we just give you some more like super concrete examples, and we'll make sure you're put a button on the unit in unit 6. It's been interesting. You guys have been doing you've been doing dominant work. I have been so impressed, and I really hope you finish it strong. Everyone in the room has been doing like honors algebra 2 level work, and I'm just really proud of you guys. So thanks. See you on the next one.